looking at them. We're not really going to talk about domain today, but tomorrow that will be the only thing we cover, so this domain idea is not going away. But today's emphasis is on composition of functions. You did this in Algebra 2, so it's not totally new. Remember your fog and goth, it's when you plug one thing into another, so that's the piece that we're looking at today. When you see this, a lot of times in Algebra 2, we first kind of drew you a little diagram to show you what's going on. If you have f composed with g of x, or you might see it strictly with parentheses, you're going to take x, you plug it into g first, you get an answer, and then you plug that answer into f to get the final piece. So it's a series of steps. It's basically a way you're going to do one calculation, get an answer, and plug that into the remaining function. So I wanted to practice first just doing some compositions with numbers, and then we'll get into variables. So let's say I gave you this problem. So I have two functions defined. When I say f composed with g of 1, you might also see it as f of g of 1. So what do you do first? Yep, put a 1 into g. So if I plug a 1 into g, that's 4 times 1, which is 4. Now you plug your 4 into your f. So 2 times 4 squared minus 3. So we get 16, 32 minus 3 would be 29. How is B different? Does order matter in composition? Yes. Let's see if we get a different answer this time. This means g of f of 1. So if I put 1 into f, what do I get out? Yep. 2 minus 3, so negative 1. So we have g of negative 1, so if you put a negative 1 into g, 4 times negative 1, negative 4. So we get very different answers. Make sure you are watching the order that you compose these things. Any questions on that one? I'm going to do a couple more with you, and then I'm going to put some up for you guys to try. You don't have to be plugging these into different functions each time. So I might ask you to do like f composed with f or g composed with g. So I'm going to put those up there to illustrate that. If I said f composed with f of negative 2. So you plug a negative 2 into f. Negative 2 squared is 4, times 2 is 8, minus 3 is 5. Now you plug a 5 back into f again. So I get 25, so 50 minus 3, 47. Last one, g composed with g of negative 1. So this time you're plugging everything into g. So if you put a negative 1 into g, you get negative 4. Put a negative 4 into g, you have 4 times negative 4, which is negative 60. Do you guys remember these? Okay. I think I might actually skip the next slide you guys have. I'm going to put a different one up here because I think you're remembering. So we're going to do another practice one, but I just want to give you one that has a few more functions and ask you to try it. So you might need to get out your notebook paper, and I want you guys to try this problem. So I've got 3 functions up here. You'll have to pick which ones you're using on each problem. If you're not done, that's okay. I wanted you to try at least a couple on your own. I think everybody's done at least that much. So this first one means f of g of 5. So you start out by plugging a 5 into g, and you get 30. So then you have to do f of 30. So you get negative 120 plus 3, so negative 117. Okay. B, you're doing g composed with g of 6. So if you put a 6 into g, you get 42, 36 plus 6, so 42. Now if you plug a 42 into g, I'm going to have to pick up a calculator there. 42 squared is 42. Alright. Is that one okay? The next few are asking you to do basically 3 things. So first you do h of 1. So if I plug a 1 into h, 5 minus 1 is 4. Then I do g of 4. So if I put a 4 into g, I get 16 plus 4, so 20. Then we plug a 20 into f, so negative 80 plus 3. And D, g of 0. So if you plug a 0 into g, we get out 0. Now if you plug a 0 into f, you get 3. And then if you plug a 3 into h, you get 2. How are those? So I put a 0 into g first, and I got out 0. Because you had 0 squared plus 0. Then you put the 0 into f. So that gives us 0 plus 3, which is 3. Then I put the 3 into h. So I got this 3.
Will it ever be like g and then another like f and then g again?
It could be. So I could really put as many of these as I wanted. I could repeat them. I could keep going as long as I chose to. And you just work on the inside out. Other questions there? Do we need more where you are just plugging numbers in? So let's talk about if I don't give you an actual number to plug in. If I ask you to leave it in terms of x. So I've defined 3 functions up here. F is 3 minus x, g x squared plus 1, and h is 2x minus 3. So for part A, f composed with g. That means f of g of x. You start on the inside. What is g of x?
3x. I mean x cubed. Then what do we cube?
No, you're just putting this. G of x is equal to x
Oh,
squared.
so you don't change anything.
No, because I didn't say g of a number or g of x squared or anything. It's just plain g of x, and I said g of x equals this.
Okay. If you put another variable in,
Then you would change that.
Sorry.
Yes.
Why do you put f in front of that?
Because it was f composed with g to start with.
Okay.
So I'm just working on the inside. So I did the g of x, which is this. Now I have to do f of that. So that means you go to f and you replace your x with this thing. which is x squared plus 1.
Now we have to just do our three and stuff.
Yes, so we run our negative through, combine like terms, and you just get 2 minus x squared. So the only difference here is we're not getting rid of our x's. We're not getting a number answer. We're getting an expression.
Thought it was gonna be more complicated than that, but-
Well, good. I'm glad it was. All right, so on B, G composed with H of X. That means G of H of X. Start on the inside. What is H of X? So now we have to plug that into G.
So 2x minus 3 squared plus 1. Then we have to FOIL.
Yeah. You're on top of it.
I was 90 on too, so I must be.
Hey, it's a good day. So you get 4x squared minus 6x minus 6x plus 9 plus 1.
So we add our other two.
Mm-hmm. Three, 4x squared minus 12x plus 10.
No, we have to simplify in
No,
that.
you do not have to factor or do anything else.
Will you ever ask us to?
Questions there? So the last one, H composed with F. That means H of F of X. So F of X is 3 minus X. We are going to plug that into H. So H is 2 times the 3 minus X with the minus 3. So you get
3 minus 2x. Now, if you had like on H, if you had like 2x minus 3x, you would have to put the equation in the
yes.
x's.
If it has multiple x's, you plug it in for both.
Will you ever have two variables in one problem, like a 2x minus 3y? And then
Oh, not two different ones, no. I might have a 2x and an x squared, something like that, but not an x and a y. Other questions? You guys ready to try one? You did? Okay. Here's your problem. So we have g of f of x. So if you plug in f, that's 5x plus 3. Put that into g. So 6 minus 2 times 5x plus 3. So 6 minus 10x minus 6. The 6's drop and you get negative 10. Do we need more practice with these?
No.
Okay.
Ready for the quiz?
Ready for the quiz? Okay.
No.
No, you're not? All right, so the next piece. I want to find functions f and g such that f composed with g equals h. All right, so what this means is f composed with g, so f of g of x has to equal h, which is x squared plus 1 to the 50. I want you to take this apart and figure out what your original f of x and g of x were. Now, there are often multiple possible answers on these. And in this one, there's probably at least 3 different correct answers. I just like to go with the easiest option, okay? If you think about this, g of x is the inside. What is on the inside over here? All right, that's our g of x. All right.
Really?
Mm-hmm.
Okay.
So if you think about when you do these compositions, you take an expression and you replace it with, you plug it into the x, right? So if I'm taking this back out, that meant this had to be an x before. So f is x to the 50. And that works. Those are 2 possible functions that if you did f composed with g, you would get that for your answer. Let's try a couple more of those and make sure we got it. Any questions on that one before I try the next one? Yes, ma'am.
Just kind of confused how you got the x to the 50.
Okay. So if I told you, think back to this previous problem. When you had f was equal to this, you went up to g, you took out the x, and you put that in its place. So if I'm doing the opposite, if I'm taking out that x squared plus 1, that meant there had to have originally been an x there. So this one, f composed with g is equal to h. So f of g of x equals 1 over x plus 1. Okay. So, your inside is g of x. It's like the first thing you would do. If you came over here, what's the first thing you would do? Do your x plus 1. So that's my g of x. G of x is x plus 1. Okay.
So no matter what, it's always the first thing you do.
Mm-hmm.
So like if it's a fraction, the first inside is always the denominator.
Yeah.
So then f of x is 1 over x.
Yep. If you took out this part and replaced it with an x, you're left with 1 over x.
Is this gonna get hard?
So it doesn't matter because whenever your outside number is always going to be the end solution.
Yes.
Okay.
So you guys do this one. Find f and g. Okay. So f of g of x is equal to this. So G is the inside, so G of X is?
2x equals 3.
Oh. So that means F of X is?
X with 1.
There you go.
So
Not the only correct answer, but probably the easiest one to get to.
I did,
What'd you do?
I put G as X.
Oh, you have to watch since G is the inside, because it said F composed with G. G is the inside, so G has to be your inside part here. Okay. Yes, ma'am.
Are we ever gonna have to do another way to find it?
No. All right. The last piece we have left to talk about is the domains of compositions, and I think I prefer to save that for tomorrow. So I think we're going to stop here today. So you have, your homework is twofold. I posted a handout on Classroom that is strictly these compositions. So that is due tomorrow. So your top priority is that handout. Now, if you finish that handout, then you can go back and start working on the Math Excel, because the Math Excel is due on Friday. So handout is first, posted on Classroom, Math Excel due Friday.